Welcome back. Today we're going to learn about how to search for values in lists. Now there are two methods we can use to search for values in lists: linear and binary searching. Now linear searching is pretty simple. It's not very efficient, but it's simple. So I want to find the number 17 in this nice list here. How would I do it? Well, first I want to say what I'm looking for. So number is 17. And then I want to loop through the list. So I say for I in range. We've done the exact same bubble sort. It's very similar to bubble sort of this algorithm. So we say 0, comma, and we want to go as far as long as the list does. So we'll say len a list. There we go. And then do the package twice. Then a colon. And for each one we simply say if list I, so the value which I is, so it's first value, second value, third value, fourth value, fifth value. If list I is equal, double equals thing is the same as number, this variable here, then we do something. We found it, yes, we found it, woohoo, well done. And we say print num, the number, then comma to link two things together, has been found at position I. So there we are. So we're saying where it is. We've said we're looking for a number. It's been found at this position in the list. So how do we do? Well, let's run it. Go to linear and select run, and hopefully 17 has been found at position 1. So we go to number 1 and we go, whoop, that's not 17, but that is. Why? Because computers start counting from 0 and humans from 1. So we're all humans, let's be nice to humans. So here, instead of found at position I, we'll say I plus 1. So now if I run it again, 17 has been found at position 2, exactly where I expected to be found. It goes through every single number and it says, okay, perfect, it finds it. But it's not very efficient. There are more efficient ways, and funnily enough, that's exactly what I'm going to show you now. Now, this is a demonstration. Say I wanted to find the number 17. I would go, and I was in a library, I had a big list of items in the right order, and so I had to find 17. What would I do? I go to the centre and say, right, is this number 17? Nope, it's 13. Right, is 17 bigger or smaller than 13? Well, it's bigger. So I wouldn't look down here to the left. I'd ignore that. I'd say, okay, 17 must be bigger than this one. So I'd look halfway in here. Is this number 17? Well, yes it is. And I found it nice and quickly. So you try and look for things by looking in half points. Halfway to things. Bigger, smaller, halfway, bigger or smaller, halfway, bigger or smaller, halfway, bigger or smaller. Now, this is quite a complex way of doing it, but it is far, far, far more efficient. So, let's see how we do it. Here's a list I made earlier, exactly the same as last time, but it's also sorted perfectly into the right order. So, let's say, what number do you want to look for? I want to search for number 4. So I'm going to say number equals 4, and we are going to loop until we find the number. One of the problems with a linear sort is it keeps searching even after it's found the number, which is very, very inefficient. We want to stop when we find it. So found equals 0. So now I want to loop until found is equal to 1. How would I do that? Well, probably a while loop. So while found is equal to 0, we are going to be looping and doing the same thing. Mistake there, I should have 2 equals there because I'm saying is it the same as, not found is now equal to 0, like a variable. So now I need to say, okay, let's set the halfway point. Where is the halfway point in this? So we make a variable called hf for half. Half equals, I want the length of the list variable divided by 2. But this could cause problems, because say I look for list hf, list square brackets hf, and say a list 2, say a list's got 9 characters, and it will say look at list 4.5. Where does it look? That is going to cause problems. The number in the square brackets in a list must be an integer. So we'll make sure this integer. How? As always, our old friend, casting. There we go. So now half is guaranteed to be an integer. Now, firstly, we now have to ask, have we found it, or do we need to go up or down? So, let's try this then, shall we? So, to ask have we found it, we use if. If a list, square brackets, hf, the halfway point of the list, if it's equal to num, which is the value we're looking for, we say, firstly, I found it, print found it, and then we say found equals 1. And at that point, the loop will stop looping. Great, you think, okay, that's efficient. But just suppose the number we're looking for isn't at exactly halfway. Frustrating, but believe me, it happens. So we now need 2 elifs, one for greater than and one for smaller than. So here we simply say, is the number greater than list square brackets hf, or is it smaller than it? Again, I'm going to be lazy here, and I'm going to copy it down below and then just change the greater than sign to a less than sign. So now we have got 2 options sitting right there. So if it's greater than, then we say, okay, we need to make the list smaller. We only want to see, if it's greater than, we only want to see the top half of the list. So, of the list, sorry, even worse, never mind, I only want to see the top half of the list. So list is going to equal list, and remember our slicing we did earlier? How do I represent the top half of a list? Well, I go hf and a colon, and that will only give me the top half of the list. And equally, if I want to say OK, I want to look at the lower half of the list, I'm going to paste it again, being very lazy. I'm going to put the colon before the half, and this will give me the bottom half of the list. So the list will be chopped in half, and then here up or down, if it goes up, it will be chopped in half again, until eventually we find the item. But how do you know what's going on? It's just going to say found it, and you're going to think, oh, that's nice. Well, what have you been doing? You don't know. So just for your own personal curiosity, put in here print upper, say I'm looking up, oh, it's the up half of this list, and also below in the lower one, print lower. There we are, nice and easy. So print upper, print lower. So we're going to look for number 4. So we should be going halfway. Nope, it's lower, so print lower. Halfway again. 6, no, it's lower. In here, for halfway, 1.5. That's going to be about 2, so rounding is 4. Is it 4? Yes. So it should say lower, lower, found it, I'd hope. Let's see, let's find out. Let's press run and see what comes out. Oh, I need to run it from here, don't I, for binary? Otherwise it will cause chaos. What's happened there? What have I done? Ah, I've got it. Yep. I made a simple mistake here. My bracket here is in the wrong place. So if I put length of the list divided by 2, then that will turn into integer. If I say I want the length of the list divided by 2, the computer won't like that. So now, if I press play again, hopefully, lower, lower, found it. Just like I asked for. Okay, let's try searching for 19, which is up here. At the other end, let's see how that works. Upper, upper, found it. Say I want to do, say, 17. Should be 1 on that, I hope. 17, upper, found it. Straight there, you see? So, today we have learnt about linear searching, where you just search each number in turn until you get it. Or we have then done a more efficient way, which is binary searching, where you search much more quickly, only 2 or 3 loops, but you do have to have a list sorted first. I hope that's helped you with your searching algorithms. Thank you and good night.